Assalamu alaikum. Welcome to this online lecture series on data mining, and in this lecture we will discuss different pattern evaluation measures, and in this lecture our focus will be on null invariance measures, which includes all confidence, Jaccard, Cosine, Kulczynski and max confidence measures. And we also compare all these measures so that we can find which of these pattern evaluation measures can perform well on different type of data sets. Similarly, we also discuss another important pattern evaluation measures, which is imbalance ratio. So as we already seen, lift and chi-square may not be very good measure examining the transactional data sets that contains lots of null transactions. So what we may like to see is what are good measures that do not influence much when there are large number of null transactions. So let's look at these different measures. Some measures, they have the property called null invariance. That means their values may not change with the number of null transactions. That means they are independent. Either there are null transactions exist in the transactional databases or not. So let's see what measures are null invariant and what measures are not null invariant. So we already know chi-square and the lift, they are not null invariant. That means their values change with the number of null transactions. So but we have found that these five measures, all confidence, Jaccard, Cosine, Kulczynski and max confidence, these are null invariance measures. That means their values does not change with the number of null transactions. So if you check their formula, their definition, they are actually null invariant measures. So you probably know Jaccard and Jaccard coefficient and cosine measure quite well. These two measures are popularly used in statistics and they are null invariant measures. But all confidence, which actually take the smaller value among A and B as the denominator, max value among A and B as the denominator, and the numerator adjusted the transaction support, the support of the rule. So similarly the max confidence is trying to find the maximum number of them. These two actually are proposed in the study of measuring association rules. Similarly, Kulczynski measure was proposed by Jaccard, who is the writer of the book which we are following in our this data mining course. So let's examine them one by one. Let's first look at null invariance. Why they are important? That means why in analysis of massive null transaction data the null invariance is so critical, because in many transactions, the transactions that contain particular sets of items, the chance actually very rare. Like if we talk about the Walmart, which is an American multinational retail corporation that operates a chain of hypermarkets departmental stores and grocery stores. So like if we talk about the Walmart transactional datasets, so they may contain neither milk nor coffee. When you try to analyze milk and coffee using the following contingency table, so this MC means the number of transactions that contain both milk and coffee. This not M not C means the transactions number of transactions that contain neither milk nor coffee. So this not M not C is a number of null transactions. Then we see lift and chi-square. They are, as we know, not null invariant measures, so they are not good at evaluating data that contains too many or too few null transactions. For example, we just look at this. For this data set, like if we talk about the D1 data set, which contains both milk and coffee, in which MC means which contains both milk and coffee, not MC means the number of transactions contained no milk but coffee. M not C means the number of transactions which contains milk but not coffee, and not M not C means the number of transactions which contains not milk not coffee. So you probably can see like a Walmart, the kind of shopping market, you probably see there could be the cases you get 10,000 transactions, 10,000 transactions that contain milk and coffee, but 1,000 transactions which contain not milk but coffee, and similarly 1,000 transactions which contain milk but not coffee. In that case, you probably see actually if people buy milk, they would buy coffee as well, because the number of transactions of both milk and coffee bought together is 10,000 in such cases, but only one of them is only 1,000, because both, if milk is bought but not coffee, is 1,000. Similarly, if milk is not bought but only bought coffee alone, which is also 1,000. So but if you have a lot of null transactions, like in not M not C, which is 100,000 cases, this value could be quite positive. So if you have very few null transactions, as in second case, which is 100 such transactions, but the remaining MC and not MC, M not C is same as in D1, so the difference is only in the number of null transactions. In first dataset D1, which contains 100,000 transactions, and in dataset D2, which contains only 100 transactions, it turned out that they are independent. You probably look at the value, they are not independent. On the other hand, if you look at the dataset D3, there is only 100 such cases in which milk and coffee bought together. So there are many more cases they bought alone, like they bought together 100 times, but they bought alone milk but not coffee, and coffee but not milk is 1,000 transactions. But once you have many null transactions, it turns out to be very positive, the number is quite big, which is 8.44. So no matter you get a very many null transactions or very few null transactions, something may go wrong. So we do need to analyze such data using null invariant measures. So we will examine this in more detail in our next slide. But for now, I hope you understand this discussion on lift and chi-square. So now we come down to compare those null invariance measures. So which one is better? We know, we probably can see not all those null invariant measures are created equal. So we want to see which one is better in all the cases. Let's just examine the two variable contingency table on the transactions containing milk and the coffee. So let's look at the cases in this data set. So the first, you look at D1 and D2, D1 and D2. D1 and D2, you probably can see the differences is only in the number of null transactions. Only in the number of null transactions. But you also can see very likely milk and coffee should got together. They should be positive, because as we can see, the number of transactions they bought together is quite high, which is 10,000 transactions, but the number of transactions they bought alone is only 1,000. So they should be positively correlated. In that sense you can see in that sense you can see all those 5 null invariant measures like AllConf, Jaccard, Cosine, Kulczynski and MaxConf. These all 5 measures give equal value. In this sense, no matter how many null transactions on the null part, they do not change their value, and also they are close to 1. As you can see, AllConf gives 0.91 in both cases. For both data sets, Jaccard gives 0.83, 0.91, 0.91 and 0.91. So they gives values near to 1. That means they are positively correlated. So the in the dataset 1D1 and dataset D2, there is only difference in the number of null transactions. In dataset D1 there are 100,000 null transactions, and in D2 there is only 100 transactions. So these are independent of null transactions. But if you look at D3, so then you look at D3 means MC getting together is quite rare, just only 100 transactions that in which milk and coffee bought together, because they get along actually very frequently, like not MC is 1000 transactions and M not C also 1000 transactions. So this means they both getting together is quite rare. In that sense, all their values are very close to 0. 0.09 for AllConf, 0.05 for Jaccard, 0.09 for Cosine, similarly 0.09, 0.09 for Kulczynski and MaxConf. So then you look at D4, dataset D4, and D4 says MC getting together or MC alone they all are 1000 transactions, like MC getting together is 1000, not MC 1000, M not C also 1000, and the number of null transactions is 100,000 cases. So no matter how many null transactions, they actually got things right in the middle. This is 0.5, 0.5, 0.5, 0.5 for all the null invariant measures, but Jaccard has a value of 0.33. Actually, this is in Jaccard, this one means its balance is right in the middle. Then we look at some trickier cases like D5 and D6. So D5, if you see, this is 1000, 100, 10,000 cases. So what you probably can see is from a coffee point of view, like a coffee guy may say, oh, MC are likely getting together. MC are likely getting together because they get along is just 100 transactions, buying coffee but not milk. But so 1000 cases they buying both coffee and milk. So but for a milk guy, they probably can see there are unlikely getting together, like milk and coffee are unlikely getting together because they bought together is in 100 transactions, but they get along is 10,000 transactions. 10,000 such cases in which people buy milk but not coffee, and only 100 cases in which people buy milk and coffee together. So in that case, you look at different measures. It's interesting, you see AllConf and Jaccard, they also it's closer to 0.9 and 0.9 and 0.09. They are unlikely to getting together, but MaxConf is close to 1. They are very likely getting together. Then we look at the Kulczynski measure, which gives 0.5. It says I am right in the middle because the tug of the war, each side is 10 to 1. So then Cosine said I am a little prone to unlikely getting together, which is 0.29. So now in D6 we change this one, the not MC from 100 to 10 and M not C from 10,000 to 100,000 transactions. So then coffee guy may said they are very likely getting together because there are only 10 transactions in which people buy coffee but not milk, but there are 1000 transactions in which M and C getting together. And similarly for a milk guy who may said there are unlikely together because there are 10,000 transactions, 100,000 transactions in which milk is bought but not coffee, and the number of transactions in which both milk and coffee bought is 1000 transactions. So now in this case you probably can see AllConf and Jaccard drop down to 0.01, which is close to 0. Even Cosine dropped to 0.1, but in MaxConf, which says I am very confident that they are very close to 1 because they are very likely getting together, but Kulczynski says I am still in the middle because it gives 0.5. they have the equal ratio. So in all the cases, which one do you like? So probably we can see D4 to D6 are the real cases that differentiate the 5 null invariant measures, but we probably can see Kulczynski measure holds firm, while in these very imbalanced cases. So but the ratio is balanced on both sides, and it holds firm 0.5, 0.5, 0.5. That looks interesting, while the other measures drop down to 1, or some other measures drop down to 0, like AllConf and Jaccard. On the other hand, Kulczynski, the cosine and MaxConf give different measures. So only the Kulczynski measure stood firm right in the middle. The other hand, we also know some cases, those cases in which some are very imbalanced. So we may want to introduce another measure which is called imbalance ratio. The imbalance ratio is introduced in the sense that the support of item set A and the support of item set B, their difference, the support of the item A and B, their difference play an important role in this imbalance ratio computation. So then you probably see for the same cases in the last three, like D4, D5, D6, in the last three cases, the Kulczynski measure holds firm at 0.5, but the imbalance ratio, in the D4 case, it is 0, because they are really balanced. Because if we talk about D4, there is 1,000 transactions in which they bought together, and similarly 1,000 and 1,000 transactions in which they get alone. So they are totally balanced transactional data set. But the imbalance ratio for D5, it is 0.89. that means they are rather imbalanced, because there are 1,000 transactions in which they are bought together, but there is only 100 transactions in which only coffee is bought but not milk, and when there is 10,000 transactions in which milk bought but not coffee. Similarly for D6, the imbalance ratio is 0.99, which is very close to 1. So it means it is very imbalanced. So as you can see that there is 1,000 transactions for MC, that means the both items getting together. There is only 10 cases in which milk is not bought but only coffee, and similarly for milk and but not coffee, there is 100,000 transactions. So imbalance ratio really can show you how balanced the two sides are. So we feel Kulczynski plus imbalance ratio, if these two presented together, used together, we will present a clear picture for all three data sets, D4 to D6, because D4 is natural but balanced. D5 it is natural but imbalanced, and the D6 is natural but very imbalanced. So let's examine these or apply these null invariance measures on a real data set. So finally I'm going to show you some real data sets like DBLP data sets, and we want to look at co-author relationship. So let's look at this table. This table is got in 2007. We study the recent dataset conferences, and we look at those authors, they publish papers and the co-author papers in database conferences. So but you probably can see the interesting thing is, for example, you look at the Hans-Peter Kregel and Martin Pfeffer. Martin Pfeffer got 18 papers, but all of them are with Hans-Peter. However, Hans-Peter Kregel get 146 papers. 146 papers and 18 was with Martin Pfeffer. So you can see in that case Kulczynski shows pretty strong value, which is 0.562. So that simply says these two authors are closely tied together in some way, but they are imbalanced as well. So if you can see based on imbalance ratio, you can easily calculate their imbalance ratio is really high. So in that case you can easily judge Hans-Peter Kregel likely to be the advisor of Martin Pfeffer. So using Kulczynski and imbalance ratio, we can easily find advisors, advisee relationships and close collaborators. So in this lecture we have discussed about some pattern evaluation measures like support and confidence, the limitation of support and confidence. After that we have discussed some other interestingness measures like lift and chi-square, and we also discussed about null invariance measures, and in null invariance measures we have discussed about all confidence, Jaccard coefficient, cosine measure, Kulczynski measure and max confidence. Similarly we compare all these null invariant measures and we find that Kulczynski measure gives better results than other pattern evaluation measures. Similarly we also find that when we applied Kulczynski measure in combination with imbalance ratio, it provides much better results than others. So finally I'll show you a bunch of papers. These are the papers quite representative on how to judge the correlation relationship. The different measures including the interestingness measure on the null invariant ones and the measures we discussed on the Kulczynski. So that's it for today's lecture. Thank you.